variables in linear, like y is equal to mx plus b. There's a straight line relationship. So both variables will be continuous and measure the intervals of the ratio scale. Normal distribution. There must be, if you want to use the Pearson distribution, Pearson correlation, the value must be in normal distribution. Data should not have any external outliers or skews, right skew or the left skew, inequalities like this. The applications like in the economics, the correlation between the income and spending, healthcare, relationship between the blood pressure and cholesterol level, those finance like this. These use cases that we have the use in checking the Pearson correlation. And then we have the Spearman correlation. The Pearson correlation uses the linear data. The Spearman correlation uses with the non-linear data or ordinal data. Like use the Spearman when the relation is monotonic but non-linear. As monotonic means one variable increases, other variable continuously increases or decreases, but not necessarily at a constant rate. Ordinal data works well with ranked ordinal data outliers. And the Spearman does not the mostly Spearman does not affect any outliers. The outliers are there, this is the fine. The Spearman works. Spearman is more robust outliers than Pearson because it uses the rank based on the raw values. Like in this formula, we have like d of I is a difference between the rank of each pair of values. Is using the d. We have the getting the rank. It's the difference between the ranks of the each pair. So we have the get the ranks and check the ranks, and the n is equal to number of pairs of the data. And the 6 is this is a p, we call as a p or something like where we use the Spearman's like relation between the students and ranker mathematics of science and social science and marketing. This is an example. I show this is an example as a Pearson. As the students time increases, student time and exam score increases. Like if a student studied 5 hours, it's a value 50, and studied 3 hours and then scored 80, 30 and 80. 8 hours studied means 80, and 2 hours study means 20 scored, and 6 hours study means 60. This means the Pearson correlation, the value is 0.99, some 9999. This indicates like the students study hours increases and the score also increases. This is one of the Pearson, the most use cases like comparison as a Pearson versus a what was the comparison of the Pearson versus Spearman. The Pearson requires linear data. The Spearman requires a monotonic, like increases or the decreases. The Pearson requires the continuous data, and Spearman continuous or ordinal. When the Pearson only deals with the bell-shaped curve, the binomial distribution data. Spearman robust data. If you have outliers, the present, it's work very well. While it's only working with ranked data, it's based on the formula. It's ranked data. The use cases: linear relationship with the clean data, the non-linear or ranked based relationship. That's it. The Pearson and linear and Spearman correlation. Point-Biserial correlation. I think this is a very low case we have to use them. Now, most of the times we have to use the Pearson correlation or Spearman correlation. As the Bayesian correlations, like a variable, a person of the correlated used when one variable is continuous and the another is a binary. They evaluate the relationship between the binary and continuous variables. Use case, the relationship between the genders, like a binary and the income. This is a binary. Have the using the binary as zeros 1 zeros 1 0 1 1. As a zeros means female and ones means male. Sorry, zeros means male and ones means female, and 0 1 0. So and the incomes as a 0 is a sorry. Zeros means female, ones means male. Zeros 10 and the 1 means 20, and zeros are 15 and 1 male is 25 and 0. And finding the correlation, it only works on the linear data. It's not working on the correlated data. Like continuous data, it's not non-linear. It's not working on the non-linear data. And then we have to find the correlation. There is a correlation between the two values is 86.85 above. That's the fine. When how the income was related as a males and female. And then we have the pi coefficient, the special case of the Pearson correlation for the binary variables. Is the special case of a Pearson correlation for binary variables. When both variables are the binary, it's a binary relationship between the two binary outcomes, as showing the example like diseases or smoking yes or not, like this. If the person is smoking is S, means 1, and the either no 0, and then and then increase the diseases. If the person smoking the 1 and the 0, there is no 0 means there is no disease, right? And the 0 is a 1, and the person is not smoking has have the disease, and the person is smoking have a disease. The person is smoking have a disease. If the person is not smoking doesn't have a disease. This like and we want to find this is any correlation. Then we have two binaries. Then we use the pi coefficients. It's got 0.616666, like this. There is a very low correlated between the person smoking the cigarette. They got any diseases like any cancers or like this.